Hello and welcome to the third video in the Maths for Scientists series. This video is all about tackling the equation, and what we're going to do in it is look at how we can scaffold answering equation questions, how it works with the simple three quantity equations, how it looks when those equations get slightly harder, and then finally the multi-equation question. So whenever we teach students how to answer a quantity equation, an equation question, we use the mnemonic QUES. So that's QUESS. So the Q stands for quantity, the U for units, the E for equation, the S for substitution, and the second S for solve. And the reason we do it this way is it follows the mark scheme that examiners have to follow when they're marking our GCSE papers. So in a GCSE paper, you tend to get marks for a correct equation, a substitution into a correct equation, and then finally for solving the equation with the correct answer. And you'll also get marks for unit conversion if there are any unit conversions required along the way. So what we do then is we ask the students first of all to read the question and identify the quantities we've been given and the quantity we need to calculate. And that's the first step of the question. And whether they want to write those out or just underline them in the question, we'd often leave up to them. But the very first step is identifying the quantities we have and the quantity we need to find out. The next step is checking the units to make sure they're in their SI format. And if they're not, they're going to convert the units at this point to put them into their SI form. Then we need to identify the equation that fits all the quantities. At this point, we're going to substitute our numerical values that we've identified earlier into our equation. And at this point, we'll solve. This is when we answer the question. So we might simplify the equation, change the subject of the equation, and go on and answer it from there by using our calculator. So how does this look in a simple three quantity question? So we've got a question here. A car has a velocity of 15 meters per second and a mass of 1,500 kilograms or 1,500 kilograms. What is the momentum of the car? So first thing we're going to do is we're going to identify our quantities. So as I'm reading my way through this, we can see that a car has a velocity of 15 meters a second. So that's our first quantity. It has a mass of 1,500 kilograms. So that's our second quantity. And then we're being asked to find the momentum of the car. So what we're going to do is we're going to write momentum and give it a question mark. We're then going to check the units. So I know that velocity should have units of meters a second, so there's no conversion needed. Mass should have units of kilograms, so there's no conversion needed. And momentum, the units are kilogram meters per second, so that's what the units of my answer will be when we get there. Now we need to identify the equation. So we're looking at this, we've got the three quantities of velocity, mass, and momentum. So the equation I'm going to use is momentum is equal to mass times velocity. So when I substitute in, my momentum is being represented by a question mark. My mass is 1,500 kilograms. And my velocity is 15 meters a second. So I can write question mark equals 1,500 times 15. And then I go to solve. And in this case, I don't need to do anything to solve the equation. So I can just type it into my calculator. And I get 22,500 kilogram meters per second. And I'm going to underline my answer just to make it nice and clear that I'm finished. And that is my answer. So this question obviously can do a few things to make itself harder, and one of those is unit conversion. So let's have a look at that now. So now saying a bike has a change in velocity of 30 meters per second in 1 minute. What is the acceleration of the bike? So if I'm to identify these quantities, my first quantity is the change in velocity of 30 meters per second. My next quantity is time, and that's 1 minute. So I'm going to write time 1 minute. And the acceleration is what we're trying to find, so we symbolize it with a question mark. Now I know that the SI version for velocity is meters per second, so that's fine. There's no conversion needed there. However, when I get to my next one, I'm looking at time. I know that the SI unit for time is seconds, not minutes, so I now need to convert. Now converting from minutes to seconds is simple, we just times it by 60. So actually 1 minute gives us 60 seconds. And in my acceleration, I know that my SI unit is meters per second squared. So I'm just going to note that there so that I know what units my answer will be in later. I'm then going to identify the equation that goes with these three quantities. So I know that my equation is acceleration is equal to change in velocity divided by time. I can then substitute in. So I get acceleration is question mark is equal to 30 for the change in velocity divided by 60 for the time. So question mark equals 30 divided by 60. And again, I can just type that into my calculator for my solvers. There's no rearranging needed. And that gives me 0.5 meters per second squared. So again, it can be harder in a different way. If there's not any units to convert, we might have to do something extra in the solve section instead. So let's look at that now. So a train is moving at 15 meters per second. It accelerates over 100 meters at a rate of 5 meters per second squared. What is its final velocity? So we need to identify its different quantities at this point. So we're saying, okay, well, its initial velocity, the train is moving at 15 meters per second. So its initial velocity is 15 meters per second. It accelerates over 100 meters, so its displacement is 100 meters at a rate of 5 meters per second squared, which is its acceleration. What is its final velocity? So we write final velocity question mark. So we can check the units. Velocity, any velocity, whether it's initial or final, is in meters per second. Displacement is always in meters. Acceleration is always in meters per second. And again, as we said before, velocity always in meters per second. So we then need to think about the equation. So in this case, the equation that I need to use is final velocity squared minus initial velocity squared is equal to 2 times the acceleration times the displacement. So I can write that equation out. Now I need to substitute. So I know that V is a question mark, U is 15, 2 is just a 2, A is 5, and S is 100. So I end up with question mark squared minus 15 squared equals 2 times 5 times 100. And the reason that we're going to substitute here before changing the subject, because we do want the question mark to be on its own eventually, is because the examiners want us to substitute into a correct equation for that second mark. And actually, if one of the areas where students make mistakes really often is in the rearranging of the equation. So if we get them to substitute into the correct equation first, they're accessing all the marks they can do before any math skills that they may or may not have get in the way. So now I need to solve my equation. And there's a few things I can do to make this easier to solve. So I'm going to simplify in the first instance. So I know that 15 squared is 225. I know that 2 times 5 times 100 is going to give me 1,000, because 2 times 5 is 10 and 10 times 100 is 1,000. So I'm also going to have to add the 15 squared onto this side to get the question mark squared on its own. So once I've done that, I can rearrange it and simplify it to say question mark squared is equal to 1,000 plus 225. And that is equal to 125. Now that doesn't give me the final velocity, that gives me the final velocity squared. So what I need to do is to get the final velocity on its own is square root both sides. So if I square root question mark squared, that leaves me with a question mark. And then I'm also square rooting 1,225. And when I square root 1,225, that gives me 35 meters per second. So the final thing we're going to look at now is using Quest to answer the multi-equation question. So again, the first thing we're going to do is we're going to identify the quantities. So if we read this, the very first quantity that comes up is actually, it's telling us what to calculate. So this time we're going to write current question mark first. We then continue going, and we see there's 1,200 joules of energy at a time of 1 minute, and it has a potential difference of 120 volts. So when we check those units, we can see the current is in amps. Energy should be in joules, so that's fine. Time should be in seconds, so we need to convert to 60 seconds. And potential difference is in volts. Now the next thing we need to do is think about all the equations that allow us to calculate current. So I think there are 3 that we use at GCSE. V equals IR, P equals IV, and P equals I squared R. And they're all the different equations at GCSE we might use that include current, with I being the symbol for current. So if I look at those, I go, well, we don't have a value for resistance. And we've got no way of calculating resistance without knowing V and I. So we can't use P equals I squared R, and we can't use V equals IR. So that's going to leave us with P equals IV. Now we haven't been given any information about power, so we need to write out the equation P equals IV, and then we're going to draw an additional line here just to show us that we're going to work out something else. Now we need to calculate power, and the way to do that is using our equation energy, or work done, equals power times time. So then what I can do is I can look at my quantities and I can substitute in. So energy is equal to 1,200, time is equal to 60, and power we'll just leave as a p for this point. So 1,200 equals p times 60. I now need to change the subject of my equation to get p on its own. So to do that, I have to divide by 60. So we get 1,200 divided by 60 equals p, which gives us 20 watts. And now we can go back and substitute into this equation because we have p, we have v, and we're trying to find I. So we can say, okay, p is equal to 20, I is equal to question mark, v is equal to 120. And we substitute into our equation. And now we need to change the subject again in our solve section to get the question mark as the subject of the formula. So we rearrange the equation, and we end up with 20 divided by 120 is equal to 0.17 amps, which we can underline to make nice and clear as our answer. Hopefully you found this demonstration of using Quest in some different settings helpful. We started using it last year with our students, and we've seen a massive difference in the abilities of our students and the confidence of our students for answering the equation question. So I really, really hope that you give it a go and you see as much success as we have. Thank you.